So, College Algebra, Section 13.2, Arithmetic Sequences. Not arithmetic, arithmetic. So, what is an arithmetic sequence? It's when you take values, let's say we start with 1, and we add 2 to that, we get 3. And we add 2 to that, we get 5. And we add 2 to that, we get 7, then 9. And 11, etc., etc. Each of these, if you would subtract 3 minus 1, 5 minus 3, 7 minus 5, have a common difference because we're subtracting. We call that D. The common difference for an arithmetic sequence is 2 in this case. When it has a common difference, then we do determine this as an arithmetic sequence. Why is that important? Because now we can figure out values easily. That's what mathematicians want. They need a procedure to find maybe the 100th one or something like that. Several ways of defining these recursively is one way that we would do it. We need the first one, a sub 1, and we'll just call that call it B. Anything you like, really. In this case, B is the 1. Gives you the first term. A sub n is a sub n minus 1, the previous one, plus some common difference, D. So, in this case, it's the previous one, 1, plus the common difference, 2. That's how we got the 3. To get the third one, it's the previous one, 3, add 2. That's how we get the 5. So the recursive definition can be helpful for short lists of this. But there can be long lists. If you would like the 100th, you don't want to start at 1 and get up to 100. You'd like to jump up to 100 right away. So this is the explicit formula. The explicit formula, maybe there's no either, okay, is now our book uses T's, A's, that's just A sub n. Okay. A sub n equals A sub 1 plus n minus 1 common differences. Does that really work? If we want, see, this is 1, 2, 3, 4, 5, 6. The sixth term in an arithmetic sequence, we need the first term and add 1, 2, 3, 4, 5 2's. Since we want the sixth one, it's n minus 1 2's in this case. That is the explicit form. There is also a sum. When an arithmetic sequence becomes a sum, then it becomes a series. And the formula, capital A sub n, is n over 2 times a sub 1 plus a sub n. How does that work? Well, let's see. Let's look at these 6 here. We're looking at, and many times they'll use an S also. I'm not sure what our book uses for a series. S sub n. S sub 6 is a sub 1 plus a sub 2 plus a sub 3 plus a sub 4 plus a sub 5 plus a sub 6. Or this sixth one is 1 plus 3 plus 5 plus 7 plus 9 plus 11. Well, let's write that again. S sub 6, but now let's write it backwards. 11 plus 9 plus 7 plus 5 plus 3 plus 1. Let's add these two together. 11 and 1 is 12. 9 and 3 is 12. 7 and 5 is 12. All of these are 12s. Now this gives us 2 s sub 6's? Because we add those two together. Well, if we divide both sides by 2, then we can figure out what s sub 6 is. So, if we look at this as the formula, n, let's see, a sub 1 is 1, a sub 6 is 11, there's the a sub 1 plus a sub n. There are n of those, 1, 2, 3, 4, 5, 6 in this case, and we divide by 2. So this formula gives you the series. This is the explicit formula for a arithmetic sequence, and this is the recursive formula for an arithmetic sequence. So how do you use this? Well, let's get a new sheet of paper. So here's a problem. They want us to show that this sequence is arithmetic. Find the common difference, write out the first 4 terms. We're going to do it in reverse order. First of all, write out the first 4 terms. A sub 1 is when you put in a 1 for this, so it's 2/3 plus 1/4. A sub 2 is when you put in a 2 for n, 2/3 plus 2/4. A sub 3 is 2/3 plus 3/4. And a sub 4 is 2/3 plus 4/4. Those are the first 4 terms. That's the third part of the question. But that's okay because that's going to help us. The common denominator here is 12. This is 8 12ths because of multiplying both by 4. And this is 3 12ths. 8 and 3 is 11 12ths. 8 12ths and 6. 8 and 6 is 14 12ths. This is 8 12ths and 9. 8 and 9 is 17 12ths. And this is 8 12ths and I guess 12, right? 12 12ths. 8 and 12 is 20 12ths. I'm going to leave it as 12ths right now because it's easier to find the common difference. Subtract these two. 14 minus 11 is 3 12ths. 17 minus 4 is 3 12ths. 20 minus 17 is 3 12ths. That's the common difference. Reduce it to 1/4. So, common difference is 1/4. The 4 terms, you need the 11 12ths, but we can reduce. Divide by 2 is 7/6. 17 12ths, we can't, 17 12ths. And then divide by 2 is 10/6. Divide by 2 again is 5/3. So this would be our reduced. Here's our common difference. Is it arithmetic? Yes, because it has a common difference. If we look at two plus 4 plus 6 plus ... plus 2n. This is number 36, I guess. And they say for this, find each sum. Well, because of this n here, this is 2 times 1, 2 times 2, 2 times 3, and 2 times n. So, if we take and subtract, we get a common difference of 2. This must be an arithmetic. So the nth partial sum is n, we don't know what that is because it's just n here, over 2. A sub 1, which is 2, plus a sub n, which is 2n. So we can even put those n's in there and find that out. If we do number 40, which is 1 plus 3 plus 5 plus ... plus 59. Now we got to figure out how far this goes, because this is still 2 and 2, common difference of 2. This is arithmetic. If we know that the sum, we don't really, I guess, know what that is, but if we can figure out how many values that is, then we can figure out what to put in as our n over 2, a sub 1 plus a sub n. Let's see. A sub 1 is 1. A sub n is 59. We just have to find out what n is. Well, let's see here. If 59 is the last number in the list, then we know that 59 is the nth term. It's the first term plus n minus 1 common differences, which is 2. And we know that's 59. So we're going to subtract 1 from both sides. 58 is 2n minus 2. Add 2, so 60 equals 2n. So n must be 30. Put in the 30 here. Now it's 30 over 2, which is 15, times 60. Or 600 and 300, about 900 there, right? So, we want to find the 70th term of the sequence 2 square roots of 5, 4 square roots of 5, 6 square roots of 5, ... Well, what is the common difference? Probably this is arithmetic since that's the section. But if we look at the difference here, 4 minus 2, that's 2 square roots of 5. And 6 minus 4, that's 2 square roots of 5. So it has a common difference of 2 square roots of 5. If we want the 70th term, we want the first term, 2 square roots of 5, plus 70 minus 1 times this common difference, 2 square roots of 5. So it's 2 square roots of 5 plus 69 times 2 square roots of 5. Let's see, 2 times 69. That's 18 to 13. 138 and 2 is 140 square roots of 5. So, remember those 3 formulas. For an arithmetic sequence, recursive formula can help with really short lists. Explicit lets you jump over things. It also helped me find that n, since I knew what the term was, and the common difference in the first term, and the sum, and over 2 times the first plus the last. If you remember those, arithmetic sequences are not so bad.